Hello. Let's explore determining particle inventory by using what we call a chemical symbol. You can see here that we have a representation of an element that is here in the purple box with the element symbol, the letter, and some numbers around it. And we're going to explain those numbers and use them to determine protons, electrons, neutrons, charge, and what we call mass number. Let's get to the first thing here, the atomic number. The atomic number is this little number here. Then for carbon, that atomic number is 6. You would know that from the periodic table. So the atomic number, it corresponds with a specific element. We've gone over that before. Then we have the mass number. The mass number is here. And the mass number again is the protons and the neutrons that are in an atom. And that mass number can vary even within a certain element because of what we call isotopes. Isotopes are the same element, but they have different numbers of neutrons, and therefore they can have slightly different mass numbers. What we haven't discussed before is charge. We have assumed up to this point that the protons and electrons are balanced, meaning that the positives balance out the negatives and you would have no charge, you'd be neutral. Well, that's not always the case. We have what we call ions, where the protons and electrons are not balanced. And we can determine that charge if we take the number of protons and we subtract the number of electrons. Protons are positive, electrons have that little negative charge here, so that we're going to build that negative in. So if you know the protons, you know the electrons, you can figure out the overall charge of an atom. And we're going to go through examples to show you how this works. So let's go down to the sheet and do some examples and see how this works. Let's do the first one with magnesium 1224. Here we go. So the atomic number, of course, is the number of protons. And you can look in the periodic table for magnesium, but you can see already that they kind of gave it to you in this chemical symbol. We can see this 12. And so that 12 tells us automatically that the atomic number is 12, and that tells us that the protons are also 12, because we've said this before, the atomic number and the protons, they have to match. They have to, there's no choice. The atomic number is defined as the number of protons, which defines which particular element you're talking about. The mass number in this particular symbol is given, where they're telling us very specifically that it's 24. And we're going to put that here. Now, some of you may be tempted to go to the periodic table and write the decimal number from the periodic table there. And that is incorrect. Remember, that's what we call average atomic mass, which actually we'll get to very shortly. But that's not what they're asking for here. They're asking for the mass of this very specific atom of this element. In this particular situation, we're going to look at charge, but there is not a number here. There's nothing here. And if there's nothing there, no pluses, no minuses, no nothing, we can assume the charge is 0. And if the charge is 0, the protons and electrons are going to be the same. So if the protons are 12, the electrons are going to be 12. Because if charge is 0, that's going to be equal to the protons. 12 minus what? Well, 12 minus 12 is going to give me that 0. So 12 electrons. Some students now, for whatever reason, start to get confused. And some students think that, once it's no charge here, they think for some reason that you're going to have 0 electrons. That would not be true. No. That would definitely not be true. So we definitely have 12 electrons. Neutrons are need to be figured out. And we know again that the mass number is going to be equal to my protons plus my neutrons. And so if we know here the mass number is 24 and we have 12 protons, we have to figure out the neutrons. Well, 12 plus 12 is going to give me that 24. And so that's all very good. I want to do 2 more examples to show you how these vary a little bit. I'm going to do this one here with the sodium. No, I'm sorry. Nope, wrong. I'm not doing that one. I'm going to do this one here with the fluorine. Now, here we can see the atomic number, again, is, oopsie, a little bit of a mess here, sorry. So, as I was saying, the fluorine has an atomic number of 9, and that means the protons are 9. We can see that the mass number is 19. And if we use that 19, we can figure out the neutrons because the mass number, which is 19, has to equal the protons, which are 9 plus what? Well, that's going to be 10. So 10 is my neutrons. That's going to be good. The charge here is a little weird because it says -1. And yeah, you can have a plus charge, you can have a minus charge. This is called an ion. When an atom has charge, when it has electrons and protons that are not balanced, you have what we call an ion. Now, to figure out the electrons, we're going to realize again that, charge equals charge equals protons minus electrons. Well, I have 9 protons. And so that goes here. Now, here's the thing about protons. You can't change that 9. Because if you change the protons, you change the element. And we're not allowed to do that. This is fluorine, F, and it has 9 protons. That is not allowed to be changed. I need this charge to be equal to -1. So 9 minus what is going to give me -1? Well, that's going to be a 10. 9 minus 10. That means we have 10 electrons. Now, we don't have -10 electrons. No. We use the negative because the electrons are negative. We already built that into the little formula, a little cheat formula that they gave. But you are going to have 10 electrons. They're going to have negative charge. You're going to have 9. They're going to have negative charge. You're going to have 9 protons are going to have positive charge. So your negatives are winning by 1. And so when you have a negative charge, you better have more electrons than protons. Now let's compare that to the next one, which is this one. When we have aluminum, 13 atomic number, therefore it better be 13 protons. Again, that has to be identical. Then we have a mass number 27, and that mass number will let us figure out the neutrons because 27 is going to be equal to 13 plus what? Well, 14. 14 plus 13. So we have 14 neutrons. The charge is a +3. Yeah, it can be positive. And don't just put 3. No. Put +3. That's important. And I'm going to run out of room here, so I'm going to put it underneath, and you folks can run it off to the side. But again, the charge is -3. Sorry, wrong. Charge is +3. And that's got to be equal to the protons, 13 minus the electrons. Well, what's going to give me that +3? Well, 13 minus what? 13 minus 10. And so I have 10 electrons here. 10 electrons. So let's look at this. I have 13 I have 13 positives and I figured out that I have 10 minuses, 10 negatives. So who's winning? Well, the positives are winning. By how many? 3. So plus 3 charge. So atoms are allowed to have uneven amount of electrons. Again, we just call these ions, and we have to determine, well, what's the balance? Which way is it leaning? Is it leaning to the plus side by how many, or the minus side and by how many? But again, the one thing I can't stress enough is that when you're doing and finding the electrons and using this equation, the protons cannot change from the atomic number. These protons are fixed. Those protons are linked to the atomic number. That cannot be altered. Only the electrons can be altered in ions. So with that said, you should be able to kind of tackle the rest of the sheet. Now, we are going to, unfortunately, because of the design of this sheet, you are going to not do a couple of these. You are not going to do this one, and you are not going to do this one. You can't do those because they don't give you enough information, especially about mass number, and if I were to explain some other things right now, it would cause more confusion than need be. The other thing is, so this one here, magnesium, it is magnesium, but they didn't write it, but there should be a 12 there because 12 is the atomic number to magnesium. And you'll note that this version of magnesium and this version of magnesium, at the top of the sheet, the very first one, they're a little different because this one is an ion. It's got a charge. Unlike the top one, which was not an ion. It's just an atom. It had no charge. Lastly, down here in chlorine, I'm going to say chlorine has an atomic number of 17. And then it just has a minus. And this minus is really a -1. If there's no number there, just a plus or a minus, it's 1. So -1. Oh, and one other thing, you'll notice here on this magnesium, it says 2+ rather than +2. Different books will do it differently. If you see a 2+ or a +2, doesn't matter. It means the same thing. Same thing here. If you see a -1 or a 1-, it's a -1 charge. So different books will use slightly different notation, but use your head and you'll be fine. So you're going to finish up this sheet and be able to use what we call and interpret what we call chemical symbols. So that is one of the most important ways and shorthands of representing atoms, ions, and isotopes. Okay? All right, we're going to come back and do an average atomic mass video on how we deal with the different isotopes and come up with the numbers that are on the periodic table. So we'll be back together very soon. Thanks.